Hey everyone, welcome back. Today we are diving into a core concept in Java, the difference between checked exceptions and unchecked exceptions. These two types of exceptions behave differently at compile time and runtime, and understanding them is essential for writing robust Java code. Let's get started. Let's begin with the basic definition. Checked exceptions are the exceptions that are checked at compile time. This means the Java compiler forces you to either handle them with a try-catch block or declare them using the throws keyword. If you don't, your code won't compile. On the other hand, unchecked exceptions are not checked at compile time. The compiler doesn't force you to catch or declare them. These exceptions occur during runtime and are usually the result of programming errors. Next is the inheritance hierarchy. Checked exceptions are subclasses of the exception class, but not of runtime exception. That's the key. Anything that extends exception but not runtime exception is a checked exception. Unchecked exceptions are subclasses of runtime exception, which itself is a subclass of exception. So while all exceptions extend exception, it's the presence or absence of runtime exception in the chain that determines their type. Here's the most visible difference. With checked exceptions, the compiler enforces error handling. If a method throws a checked exception and you don't handle it or declare it, you get a compilation error. This is Java's way of saying you must be prepared for this to happen. But with unchecked exceptions, you can write code that throws them without handling or declaring anything. The compiler doesn't intervene. The assumption is that these are developer bugs like null pointer access or array index issues and should be fixed rather than handled. Let's look at some examples you can call out in your table. A typical checked exception is IO exception. This happens when you are reading or writing files and something goes wrong. Another common one is SQL exception, which occurs during database operations. For unchecked exceptions, the most common is null pointer exception, which happens when you try to access a method or field on a null object. Other examples include array index out of bounds exception and arithmetic exception. So again, checked exceptions are about things beyond your control, like external systems. Unchecked exceptions are mostly coding mistakes. What kind of problems do they represent? Checked exceptions are generally recoverable. That means the program can handle them gracefully. For example, if a file is missing, the app can prompt the user to select another file. Unchecked exceptions are mostly programming bugs. They are logic errors like trying to divide by 0 and usually mean something in your code needs fixing. This is why unchecked exceptions are considered preventable, while checked exceptions are just possible outcomes in an uncertain environment. Now, how do you handle them? Checked exceptions must be either caught or declared. That means every method that calls a method which throws a checked exception must either wrap it in a try-catch or include a throws clause. Unchecked exceptions are optional to handle. You can catch them if you want, but there's no rule saying you have to. This gives developers more freedom, but also more responsibility. Let's talk real-world usage. Checked exceptions are great when the caller is expected to handle failure. For example, when reading from a file or connecting to a server, the caller might want to retry or display a user-friendly message. Unchecked exceptions are better for cases where errors should be fixed, not caught. For instance, a null pointer means something went seriously wrong, and you usually want to fix the bug rather than catch the exception. So to wrap it up, checked exceptions are compile time exceptions. They force you to handle possible failures and are useful for recoverable problems like IO or database errors. Unchecked exceptions are runtime exceptions. They don't require handling and typically represent bugs in your logic like null access or index mistakes. Knowing when to use each one and how they affect your code is a key part of writing clean, reliable Java applications. Thanks for watching, and I will see you in the next one.